Hello, today we're going to talk about nonlinear functions. All right, the first thing you need to know is to have just a little common sense here. All right, a linear function, as in the word linear, when you think linear, you think a straight line. This is a linear function. Specifically, it is in the form y equals mx plus b. That's called slope-intercept form. It has a y-intercept and it has a slope. Don't worry about that right now, but it's a straight line. So what would a nonlinear function look like? Well, something that's not a straight line. So that is not a straight line. That is a V. That is not a straight line either. That's a U, but these are still both functions. This is what is called a quadratic, and this has to deal with absolute values. They're still functions, they're just not linear functions, which is a straight line. And this is a linear equation. And there you go. So nonlinear means it's not a straight line. So anything that's not a straight line is nonlinear. It always weirds me out when people don't get this. Nonlinear. Linear is a line. So if you see something that's a straight line with two arrows on the end, it's linear. You see a V or a U or some other shape, nonlinear. All right, the other thing with a linear function real quick, if I wanted to know a bunch of points for a linear function, all I have to do is make an XY table. Give yourself a function. You can make any linear function you want. Y equals x plus 5. Now I want a bunch of points, so -2, 0, and 2. Plug that in, so -2 and for the x, 3. There's 1 point, 0 and 5, 2 and 7. There you go. There's 3 points that make up a linear function. All right, the first thing we're going to talk about is absolute value. All right, an absolute value shape is a V. There you go. And it'll look like this. So y equals those things. I'm going to color them a different one because I found if I don't, I write pretty fast and it gets sloppy. So it starts looking like a 1. All right, so those are just 2 bars around it. Those are called the absolute value. What the absolute value is, so if I said y equals -2, absolute value means you turn everything in there to positive at the end after you solved it. So the answer to this is y equals 2 because it turns it to positive from negative. If I had y equals x plus 3. And I said x is going to equal -2. I plugged the -2 in for it, but I have to wait to solve it. So I get y equals the absolute value of 1, so it's just 1. You don't switch it over to negative. All the absolute value means is whatever answer you get when you solve, you make it positive. All right, so let's graph one of these real quick. So let's say y equals that. All right, now we'll do something a little different. There we go. So now the graph, you make an XY table. Right? I always use the same exact points for everything. It just, I don't know. I just always use these 5 points. And as I go through this and other lessons, these will be the ones I almost always use. -2, -1, 0, 1, 2. I like them on both sides of the y-axis. All right? So now I plug these in. I'll do the first couple out for you just so you can see. Times -2. So -2 times -2 is 4. So y equals 4. Now we plug in -1. So y equals -2 times -1. So y equals absolute value 2, so 2. Then 0 will give you 0. Alright, now here we go. So this one right here, the 1. So y equals -2 times 1. So y, -2 times 1 gives you -2. Absolute value of -2 is 2. Right? Notice here, we did not, that was just regular 4, we did not turn it negative. Alright? It was negative, so we made it positive. So 2, and this next one is 4. Now graph it real quick. -2, 4, -1, 2, 0, 0, 1, 2, 2, 4. There you go. And that is how you graph an absolute value of a function. Is it linear? No. All right, here's another example. This one has the negative on the outside of the absolute values, so it works a little bit differently. Again, we'll go with -2. I'm actually going to shorten this up a little bit. Do -2, 0, and 2 just for time's sake. All right, so I plug in -2 here, so I get y equals negative. Treat these as parentheses. 3 times -2. So y equals negative, gives us -6. So absolute value makes that just 6. And then you multiply the negative to get -6. There you go. So then 0 will just give us 0. And now we plug 2 in. So y equals the negative, again, treat these as parentheses. Right? So then you'll distribute the negative to it afterwards. So whatever number you get is going to end up being negative because of that on the outside. Absolute value of 6 is just 6. Bring the negative in. And there you go. Now we graph it. -2, -6, 0, 0, 2, -6. And there you go. That's how you graph absolute value that has a negative on the outside. All right, for this one, we're going to do quadratics. I don't know why you have to learn quadratics at this point, but they want to show you a different nonlinear thing. So let's go for it real quick. So y equals x squared minus 2x plus 1. As long as you can substitute a number in, you can graph a quadratic, because it's done the same exact way. The shape of a quadratic is a U. Alright, just for this case, I don't like doing this, but we're going to shorten it just for time's sake and do -2, 0, 2. We're going to plug those in, see how it looks. So we plug in the -2. So -2 squared gives you 4. -2 times -2 is 4 plus 1, 9. Zero, plug it in. So that's 0 squared minus 2 times 0 plus 1. So y equals 1. And then we plug in 2 again. So y equals 2 squared minus 2 times 2 plus 1. So 4 minus 4 plus 1 gives you 0 plus 1, y equals 1. So we missed out on the, we missed out. Let's do one more just so we find the vertex. The vertex is in between those two. Don't worry about that. So we're gonna put a 1 in there. We're gonna find what it is when we use 1. So y equals 1 squared minus 2 times 1 plus 1. So y equals 1 minus 2 plus 1. Y equals 0. There we go. Our vertex. Vertex is the lowest or the highest point in a U. Alright, I wanted to find it just so we could get this a little bit more accurate. Alright, so now we graph it. We get -2, 9, 0, 1, 2, 1, and 1, 0. Connect the dots. There you go. That is solving and graphing for a quadratic. It's done the same as the absolute value. The only thing you're doing here is you just have to do the squared. In the absolute value, you're just making it positive at the end. I'm gonna do one more example of this. All right, here we go. Here are all of our x's, our inputs. Remember, for every one input, you only get one output. Now with quadratics, this last number here is your constant, or it's gonna be your y-intercept. So I know when I graph this on the graph, my u is gonna cross on the y-axis at 4. And the last one, when I had y equals x squared minus 2x plus 1, I knew that my u was going to cross on the y-axis at 1. Because that's your y-intercept. That's where it'll cross. So that's just a little thing to remember as you go. You can always graph it to see anyways, so it doesn't matter. So let's plug this in. Go in order of operations. So that's 12. That's 6. 0 gives us 4. Now we plug in 1. So that's 6. So I know this is going to be 12. Now we graph it. This is all about plugging stuff in. If you can plug stuff in, you can find the answers. This is y. This is why when I teach this in a regular class, when we're doing equations, I always make people do a check at the end, because you have to get used to plugging numbers into equations and solve it. I don't like that they didn't do that in this program, but there's no way to really do it. So and there you go. It's all about plugging in numbers and getting an answer out. And that's how you do it with. All right, and the last thing. We talked about, I showed you how to graph two nonlinears. That's absolute values and quadratics. Some other nonlinears are when you have like x equals something. Because when you have x equals something, that's not a function. That's not even a function, so it doesn't matter. And if you have a square root of like x minus 2, all right, that's not a linear function either. That's a nonlinear function. All right, this has been nonlinear functions, basically graphing, quadratics, and absolute values. I hope that helped, and good luck.